Hi all, this is Ram from IIIT Bhubaneswar, and I will describe about how to download and use the RVIN detector toolbox. The download link is this one. Just copy this one, open up your browser, paste it, and you will find tool underscore git underscore hub. Just make a clone to download it. After downloading, just paste it somewhere you want. I have pasted it in the desktop itself. You extract it, and after extracting, you just open this and you will find RVIN detector toolbox master. Open this one, then open the tool underscore git underscore hub, then open the tool underscore one in the Matlab, then run it. And when it will ask to change the folder, you select this one, change the folder, and now you will get one GUI window. Within this, initially we have to add some image, we have to select some image, and you have to press this button for selecting the images. I have given some sort of images in the image folder, and here I will select the Lina image, and after selecting the image I will add some noise to it. And in the paper I have mentioned that the noise density is P, which will vary from 0 to 0.9, which defines the noise density, how much of amount of noise I want to add. And this is the M with the randomness parameter, and I am varying it from 0 to 120. So initially, in order to add some noise, let's take, I have selected around 80% of noise, and I have selected the M value around 5. Then you just press the add noise. So you will find the image is corrupted by 80% of noise density and with the randomness parameter of M. Along with this randomness parameter, you can find the histogram of the original and the noise is like this. If I will increase the value of M and I will add it, you can find the value of this red colored histogram is increasing more, as it is 41. So it is varying from 0 to 41. This is one distance, and here from 255 minus 41 to 255. So with various of M value and various of noise density, you can check the effectiveness of the algorithm. So let's check with the noise of 80% and M value 8, and then I will and you can see this is the noisy image and it is the histogram, and wherever the noisy image is not equal to the input image, the ground truth mask M is obtained. So M where S is not equal to X. Then different noise detection algorithms has been mentioned here, out of which we have to select which type of algorithm we want to use. Here we will use USND, which is the unique statistical noise detection, which is the proposed one. By using unique statistical noise detection, initially I will detect where the noise is present within this image. For this thing, a window is created, and accordingly the unique values are sorted, and the noise is being detected accordingly. So this is the noise mask 1, which is obtained by the unique statistical noise detection, where we have some false alarm is 377, misdetection is 0, and the noise mask 1 accuracy is this thing, DPR, the detailed preserving rate, and FDDR is 1. FDDR is your false detection and deviation rate. Then if I don't want to use the noise histogram processing, which is the post processor to the previous selected noise detection algorithm, if I am not going to use this thing, then directly this noise mask 1 will be updated as the final noise mask 1 over here, final noise mask 1 over here, and this noise mask is compared with the ground truth mask, and wherever deviation is there, it is being displayed. So you can see the PSNR of this thing is and after this, a basic filtration algorithm, adaptive cluster switching median filter, is used for all the purposes. Here the filtration is made fixed, and here the performance measures can be calculated, and this is being shown here. It is PSNR is equal to 26.7 and SSIM is 0.79. And you can see, as we have not done the post processing, the false alarm remains same, for misdetection remains same, everything remains same. So with no post processing, we got the PSNR around 26.7 and the SSIM is 0.79. Now if I will apply the noise histogram process as a post processor to it, at this time it will take the noise mask 1 as a input, and it will calculate the noise histogram within that image, and by finding its derivative, the minimum and the maximum of the derivative and its respective locations are marked as B1 and B2, and you can see the B1 and B2 are updated over here as a threshold through which the noise mask 1 will be reduced to the noise mask M with the help of noise mask 2, and the final noise mask is compared with the ground truth mask M in order to find the deviation over here. And you can see in the first approach, when the noise mask 1 was obtained, the false alarm was 377, but after processing the noise histogram, we found the final noise mask NM is not having any false alarm and misdetection. And you can see the accuracy and the DPR and the FDDR all is one. And you can see the SSIM has been increased, the PSNR also has been increased over here. However, one can change different sort of algorithms also, and here I have used the boundary discriminative noise detection. By using VDND approach, the noise detection mask will be calculated. This is the noise mask 1, and we have to wait for a second. And you see the noise mask 1 has been updated, and here the false alarm and the misdetection has been mentioned. Likewise, if I don't want to use the noise histogram processing, then the output will be the noise mask 1, and accordingly the filtration is being done over here. Likewise, if I will go for the noise processing, we will find after the processing the false alarm has been reduced. Thank you.